So I'm going to explain what a cross product is, but I think it always helps if you have a visual. Because when I first started doing this, I didn't really understand what I was doing. I knew it was giving me a result that I could plug into a system, but I didn't really have a visual understanding of it. So what we have here is just a vector. You've seen this before. I'm just using this as a visual guide. So say you have a vector in 3D space going somewhere, right? And you have another vector. And this could easily be an elbow. You could imagine this would be our elbow, right? So you have basically any two vectors kind of going anywhere in space, no matter. And they're both, say this is the elbow and this is the wrist and the shoulder, whatever. You can imagine that, okay? I'm going to leave that to your imagination. Hopefully you have a little bit of imagination there. So whenever you have two vectors like this, and they're at any angle from each other, there is always an angle that is 90 degrees away from both of these. And to illustrate that, I'm going to show you these are planes. We'll just call them triangles because remember how I said everything is a triangle. But wherever these two edges meet, these two rotating triangles can rotate around this axis, that is, this vector that could rotate. And when it does meet up with this other one, it forms a vector that is exactly 90 degrees from wherever these guys are. So you can imagine, I'm going to go ahead and turn this guy on so you can see it. So this will be the vector that is 90 degrees apart. So no matter where I move this guy in space, it could be anywhere, you'll see there's always going to be some way between them that is 90 degrees apart. Okay, so these guys could be anywhere in space. There's always going to be a 90 degree issue. When cross product fails, where cross product fails is when these two guys point in the same direction. So as they get closer to each other, you see there's kind of this really weird kind of flipping that occurs, and it gets very unstable. So they're basically parallel vectors, or if they're facing 180 degrees apart. So I'm just kind of visually getting this here, and you can see as I reach 180 degrees visually, you can see that cross product kind of becomes unpredictable. It's kind of flipping here, right? So later on when we're doing our calculations, sometimes when you get a character, his arms, like in the Toonie characters, their arms are perfectly straight out to the, in a T-pose pretty much. And it gets really hard for you to kind of align joints if things are exactly straight out. You get this weird flipping. So we'll create like a helper to kind of give us the angle that we're looking for. We'll explain that later. Now that I just wanted to explain what it is that you're looking for. So we'll be given two angles, these two guys, arm and forearm, maybe upper arm and forearm. We have to find the 90 degrees off cross product of this. So I'm going to show you how to do it in PyMEL real quick. And to do that, I'm actually going to turn on some values here. So here is, you've seen this before, this is our x vector from the origin of where these guys are kind of rotating from. So it updates live, you can see that. And let's go ahead and turn on the gray guy too here, okay? Shift H. Okay, he's hidden. So what I want to do is I want to magically figure out what this vector is right here. And then once we get that vector, we're going to do cross product yet again to get another one. And I'll show that to you real quick here. So let me go ahead and open up the script editor. Okay, let's clear our history like we always do. So the very first thing we're going to do is we're going to go ahead and call xvec is equal to pm.dt.vector. And I'm just going to leave it open parentheses. And in this screen, let's go ahead and find the x value right here. I'm just going to select this guy and open up the attribute editor. And as we did before, I can just cut and paste this value in here because I'm lazy. I don't like typing that much because as you've seen, I make a lot of mistakes. Okay, so that's our first x vector. Let's go ahead and get that. And then we'll get this other opposite. I'm just calling it the opposite vector for now. So we'll go ahead and get that. So we'll call it opvec. pm.dt.vector. Okay, and we'll get that from the attribute editor. Paste it in there. If you watch a previous video, you'll see that I've done this twice now. So, okay, so let's go ahead and establish these vectors. So let's just check the length of these just to make sure they're close. Length. And it's close to 1, but it's not close enough. So what I can do is I can just say, okay, in place, I can say normalize. So this takes the vector in place and normalizes it. Oh, I have to spell it properly. What's wrong with me? Okay, so let's normalize it. Let's clear the history. And let's check the value again. Before it was 9.4. And now let's go ahead and check the length. It's 1.0 now. Okay, so let's do the exact same thing for opvec just to look at it. Opvec, let's check the length. My visual device here is not always mathematically accurate. Okay, so that's not even close to 1 either. So let's do the same thing for the opvec. Opvec.normalize. Spelled properly, hopefully this time. Okay, and let's see opvec's value now. Okay, and opvec's length is now 1.0. So now I know these two vectors are now the value of 1. And I need normalized values to find this cross product right here, to find this value up here. I want to find the direction that this is pointing. Okay. Okay. And now let's go ahead and do that. So I'm just going to say our y vector, because it's green, I'm going to call it the y vec, is equal to opvec dot cross, and then I just insert the other vector, x vec. It's very simple. There is another way to do it where you would just say pm.dt.vector.cross, and then you insert vector 1 and vector 2, but I like the method version better myself. Okay, so it gives me a result, but this result is never normalized. So, because if we actually check that y vec is equal, let's just check the length. Okay, it's not normalized either. So what we want to do is we definitely want to normalize it. And we can do that as we're calculating it. We can just, with methods in object-oriented programming, you can stack them. Remember in Chapter 1 I showed you that. So you can just stack them together. So let's just do normal. And we'll just tack that onto the end here and run that again. Now let's check the length. It's closer to 1. It's 1. So let's go ahead and look at this vector here. Let's look at this vector. Okay, so here's the value of that vector right here. Let's see if this matches. So 0.098, 0.098, 0.84, 0.84, 0.533, 0.53. So this value that is up here, that is floating around, and I can go ahead and just, it'll change right now. If I move this, it'll change. But I just wanted to show you that this is how we can calculate the cross product. You basically take one vector and get the cross of the other. Now you'll get the opposite direction, the opposing vector, if we were to reverse this. So if I wanted to get, if I'm not getting the vector, the cross product I want, cross product, there's always two values. There's one going in one direction and one going in the other. So there's one exactly on the opposite side of the screen, the negative direction. So you can, if you're not getting the value you want to swap the calculation. So you would do y vec neg is equal to x vec dot cross op vec, and then add the normal at the end, like this, and you'll see it's a negative version of the exact same, so it's pointing in the opposite direction. All the values are negative, and these ones are all positive. So here's the cool part. No matter where I move, well, no matter where I move this gray one, this one we're calling the opposing vector, I know this green one will always be 90 degrees away. So if I know that, I can take this guy, this vector, and get the cross product for them and get a fourth vector which points exactly 90 degrees. And this is the corner that we're looking for. So we can move this corner to wherever we want. I could, theoretically, let's just turn this on, Shift H, and let's show joints. Show joints. Okay, we could have these guys pointing down this axis and down this axis, and then I would get the cross product, which is basically pointing up this way. I hope you can see my cursor right here, so it would be pointing up this way. You could do that. And that's what we're going to do. So now that we will be getting you can use the cross product a second time to get this value. And then we will get our corner, and we can create a matrix, and we can make an object assume the same position as this little visual aid right here. So I think that's what we're going to do, and stick with me here real quick. So I have to redo all of these values to get my x and opposite. So let's just delete this part. Delete this part. So let's get the new one. Actually, I don't need the first opposing one. I'm just going to go ahead and turn that off, Control Hide, and I'm going to use these two to calculate this one. That's all I really need. So I will say x and y vec, and this will give us our z vector. Okay, we'll get rid of this guy right here. So let's get x. Don't let the code go off the screen. Don't do that again. Okay. What happened? Oh, parentheses at the end. It always helps. Okay, let's get this guy. PyMEL is helpful, but it's not going to spell check for you. So let's go ahead and normalize these. We already know they're probably not going to be 1, so I'm going to normalize them in place. And I'm going to say the z vector is going to be y vec. And I'm not sure which direction it's going to be, the positive or negative, so we're going to figure this out right now. So let's go ahead and look at z vec. And let's turn on the visibility. So it's negative, positive, 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 negative, negative. So it's the other way around. So what we'll do is we'll do x cross product with the y. And that will be our z vec. Okay. And now they will match. So we got minus 0.481, minus 0.481, pretty much, minus 0.303, minus 0.303, rounded, minus 0.306, minus, wait, this one, minus 0.823, minus 0.823. And now, if we got the translate position of this guy, so we can just look in your channel box and get this value right here. I don't have a helper for that, but I can make a matrix and I can set an object to that. So let's go ahead and just do what we did in the previous video to show, but this time I'm going to turn off the visibility of joints because it's distracting. I just want to show vectors. And I'm going to create a cube, polygon cube. And I'm going to make it assume the position and orientation of the vector matrix that we're about to create. And this cube would represent a joint. Okay. Okay. So here we go. So let's say we'll say cube m is equal to pm.dt.matrix. And we did this in the last video, so this is nothing new. So we're just going to go up here and say x vec, y vec with a comma, z vec, and trans. So I'm not sure what trans is, so what we'll do is okay, so let's go ahead and make this a pi node real quick here. So we'll say the cube is equal to pm.pi node, and it is, let's just say pm.selected because I'm lazy. Index into that list. So the cube is this value right here. Make sure the code's not going off the screen. And let's look. So the cube is p cube 1. Okay. So let's go ahead and create this. And let's move this up here. Control X. Let's move it up here because in order you would want to do this first. So the cube is there. Now let's say the cube dot. No, we don't want the cube. I want this guy right here. So we'll just get these values. And I'm just going to make a matrix. I'm just going to plop in a vector right here, pm.dt.vector, instead of assigning it. So I'm just going to say 3.564, comma, 8.896, minus 2.938938. And let's go ahead and close that. Let's see if this makes us a vector. A matrix. So we do have a matrix. Now I'm going to say cube, go to that matrix just like we did before. The cube. Set its matrix to be cube M. And there you go. So this is what we're going to do. We're going to write a script that's going to go through. We're going to have our opposer right here. We're going to have two opposing vectors. It'll be the forearm and the elbow. I'm going to hide this now. Then we're going to use that to get the y vector. And then we're going to use the y vector and the x vector to get the z vector. And that'll give us our corner. And that is what we'll use to align our joints, just like we did that cube. Okay, let's write that script right now.